Good morning, everyone. I'm Jim Giacchetta, co-founder and CTO of VidOvation. And today on our Wednesday webinars, we have a very special guest, Stefan Dupucu, Director of Global Sales from Dream Chip Cameras. Welcome.
Yeah, thank you, Jim, to give me the opportunity to show our stuff. So excellent. So should I start now? Yeah, it's all fine.
Yeah.
Okay. So let's start with that. So good morning, everyone in US. So I'm Stefan. I'm based in Belgium. So I speak French and English, but no German. Even if my company is German. So I will explain you a little bit about Dreamship. Of course, I have really nice toys here. So I will be able really to show you some nice pictures and some demos. So stay tuned because I will really get into details about, how the cameras work, what's the difference with the competition, and some example of slow motion, because we do a very nice slow motion camera as well. And I will also end with some use case. One is really nice. So I will spend some time to explain you the background of it, Jim. So let me maybe start with the presentation that's it. So sorry for the quality of the video. It seems that it's a bit not super good picture quality, but here it's working fine. But I will try to really be slow on this. And Jim, just let me know if I need to put some more light on some information. So as I've told you, I will start with the introduction. So speaking a little bit about Dreamship, who we are and what we do. Then I will jump into the ATOM cameras, the very small cameras that we have. So that's this kind of really mini cameras, like POV cameras, but they are a bit special. So I will explain you why. Then slow motion, and then some words about Barracuda, which is our streaming platform, H.265 SRT platform, which I think has really nice features. Let me maybe start with a very interesting white paper from Infront, which is huge, of course, a older company. With this COVID times and remote production stuff and everything, these empty stadiums. So the thing is that they were writing that they try to get more camera angles, new perspectives, and I really believe that's what we do at Dreamship. So I was really happy to read that from them, and that's really what we do at Dreamship. So it's really to bring you new tools, new angles, new cameras, really small cameras, but broadcast quality. I will show you that just after, but I think it's really what we do. So start with Dreamship, Jim. We are, Dreamship is kind of old company actually, because some of my colleagues knows each other for 30 years, so 30. So it's not a new company. But we decided really late to do our own products with our name on it. So before that, we were doing a lot of OEM products for a lot of manufacturers, not only in broadcast, because our main focus is really FPGA development, sensors, video processing. So that's really our DNA. And so when it comes to Dreamship, we have around 125 engineers. So it's not a small company. It's not huge, but it's 125 guys. So it's really technical, and it's really deep engineering that we do at Dreamship. So we are based in Germany, Hanover, if you know it. So we have 3 sites in Germany, and we bought last year a company in Holland, NXT, so Philips, and then Samsung. So we got 25 more people last year. So as I was saying, Jim, we don't do just cameras. That's one of the business unit we do. We are really focusing on mobile phone automotive products. So just to give you an example, I don't know if it's really popular in US, but the new Audi, the new electrical car from Audi, you don't have the side mirrors anymore. That's cameras, and that's our technology. So we are supplying Audi with the side mirrors. A huge business, as you can imagine. It's really about picture quality. There's a lot of constraints around that. So, I mean, that's really our main focus. But my CEO decided really to make cameras and put our name on something and do something different than what is existing on the market, of course. We didn't want to compete against our customers, which makes sense. And so we decided to do this. So we have two lines of products, cameras and IP streaming devices. So I will start with the cameras because we have really, as I was saying, really nice toys at Dreamship. So I will explain you what we do. So basically we have 8 different cameras from HD to 4K. And I think that we are the smallest on the market. So we have really tiny camera. They are all 1080p HDR. So you can have HLG, PQ, S-Log3 on every single model that we have. So it really goes from the very small one. So I will show you some specifications. You'll see it's really crazy small. With the Atom 1 Mini, the Mini Air is really, really small. If you remember, Jim, I mean, 2 years ago, Riedel was doing this Red Bull air race with the planes, you know, flying around.
Right.
And so this Atom 1 Mini Air was specifically developed for them. So they really needed a very small camera, maximum picture quality, SDI. Of course, all our cameras are SDI with full control. So I will show you also how we control the cameras and what are the kind of broadcast control we can get on the camera. If you're not familiar with cameras, I will try to explain you in details, of course. But if you know a little bit about that, you'll see it's really a full feature broadcast camera. So we have all the features that we need, which is really important. And I will explain you just afterwards why it's important. So let me maybe jump into the details. So of course we are all over the world, especially in US. We have our cameras already on big events, from MLB to golf with the US Open. I will show you some pictures, but we were at the Super Bowl this year. So I mean, we have really nice references. This is what I was trying to explain you with the picture quality. So the most important when it comes to a broadcast production is that all the cameras looks the same, which is a challenge because all the sensors, they look different. So they see the colors differently. You see, so let me give you an example, Jim. If you have a football match, what is important is that the green of the grass is the same on all the cameras. So when the director is switching to one or the other, the greens should be the same. The blue of the sky, the colors of the jersey should be also the same, because I mean, they don't like that the picture looks different because then you see that you are using a different camera. Mm-hmm. And that was really one of the weak points of the actual POV on the market. I mean, as we say, you pay for what you get. They are really cheap. They were really cheap, but then you get for the money you pay. So here we are really bringing a value on the camera. Don't get me wrong, Jim. The pricing is really affordable. When it comes to slow motion, we have really the cheapest slow motion in the industry, but really cheap. But quality is not cheap. You will see. So here it's really important to have a tool that helps the vision engineers to paint, to shade the camera to the main camera. And that's what we call multimatrix. So if you're not familiar with multimatrix, so you see here a vector scope, and the vector scope is just showing vectors of all the colors. So we can have like 12 vectors, 24 vectors, 48. So it's really, really precise. Most of the engineers in the field, they are happy with 12 because it takes time to really match everything. And with 12 vectors, you can cover really all the range of colors. So let me show you maybe how it works. And let me maybe explain what is my setup here. So I have different cameras. So let me maybe jump to this view. I got different cameras here, including the slow motion, the Atom 1, the Atom 1 Mini, the 4K. I got some RCP to control the camera. So I will be able to show you that also and how we paint the camera. I've got some PTZ controllers for the pan tilt head. I will also explain you that. But let me maybe show you this first one. So let me just disappear for a few seconds. So PowerPoint, demo camera. So this one. So let me disappear for a while because I would like to show you the bottom right, or maybe I can zoom into it. That's going to be more visible because maybe picture quality will be better. So let me maybe jump into the full screen. So you see here my color chart and a green Mercedes at the back and my turntable really at the front, far back for my slow motion. What I want to show you here is the multimatrix because it's a very important tool that we have, which is unique. So multimatrix usually are used in the very expensive CCU from Sony, Grass Valley at a really different level of pricing. So I'm speaking euro, but that camera I'm showing you at the moment is 11,4900. So 1149 euro. So around $1,500, something like that. And you have multimatrix on those ones. So how does it work? So here I will play with the RCP. I will go on the right camera and I will enter my menu to get my multimatrix. So I will come back to the camera view. So this is what we call a gate effect. So the gate effect is really cool because it will highlight the color you want to change. And what is important, when you do that and when you change that color, you change only that color. So that means that you are not moving the other colors. So you're just moving the red, the whatever color you are selecting on the vectors. So as I've told you, Jim, we have like 12 vectors, but that can be more than that. So let me go maybe to the green of the car. So this is the green of the car. And let me just change the color. So I will put more saturation like this, a little bit of hue. So you've seen, I hope that the quality is good enough that you've seen the color changing. Then I will just put back the other colors. So just the green has changed. The other colors are the same. So if I take out the multimatrix like this, I'm just go back to normal. And if I activate them, then just the green is changing. And I can do that individually for every color. So you can calibrate my camera and really match it to almost everything. It will never be.
So like you said, the football player's jersey, if it's an odd color, you can target that one color and make the jersey
or pink or exactly. So so that and that's really important again because they should all look the same. And so with those multimatrix and combined with the RCP I'm using, I will come to the RCP just after. I mean, you can make presets, you can make group of presets. Everything is saved in the RCP, which is also very interesting because you can save it in my cameras, of course, all the presets. But if you have a failure in the field, then you can just change the camera and the RCP is pushing back the right values to the camera. So it's really quick and efficient if you need to change something in the field for whatever reason. So so that's really easy. So
Stefan, this is very unique in a low cost $1,500 camera to have these kind of broadcast, hooks, controls, color balance. That there's nothing else out there like that, right?
Absolutely, Jim. So there's no one that does that. I mean, some of them have some basic correction, like a very famous brand in US that I will not name here, but no, everybody knows those POVs. They don't have those kind of tools. So I mean, again, that's decent cameras for the price you pay. It's maybe good enough for some people, but if you want to get to the next level and really get something at some good pricing, then we do something unique that nobody is doing, indeed. So
Very cool.
and as I was telling you, so we really have like almost everything. So let me maybe jump to the RCP. So here, Jim, I'm using a Cyan View RCP. So let me maybe show it like that.
I've heard the name before. We've been
think
working
so.
with them a few months now. You used to work at Cyan View, correct? Earlier on.
Yeah. So David, which is the founder, is a good friend of me, and we founded the company together like a few years ago. And previously, we were working together for a slow motion company called iMovix, which was quite popular in US. So Fletcher was one of our biggest customer, and they were really using a lot of iMovix system. And then we launched the Cyan View and went for the story. So let's be together. We are the two of us, right? So let me maybe explain you a story. So when we launched Cyan View, we were looking for mini cameras, and we checked a lot of cameras, and the best we found was Dreamship. And so we based our development with Dreamship camera, and then for some personal reason, we decided to split with David. And then it was a natural move to go to Dreamship for me at the end, because I was already selling a lot of cameras for them. So it was really natural to go there, but also interesting because I was knowing already really well the product, because that's the one we selected before. So that's the link, and yeah, some story between us. So
Yeah. So it's good though that we're all kind of in the same extended family, which is good.
that's exactly the idea. So here you have some arrows at the really bottom of the RCP. So you see maybe on the screen, let me put it like this, you see the name changing. So with one RCP, you can control as many cameras as you want. So it's really no limitation. And if you would have like other cameras like PTZ camera from Sony or Panasonic at the same time, you can control different protocol at the same time. And see how quick it is to go from one camera to the other, and getting the feedback from the camera. So you see really the value changing. So with one RCP, you can control as many cameras as you want. I have 6 cameras now. I'm switching from them, and I can switch my my video matrix at the same time. So if I go to my quad, actually that's the RCP that is switching at the same time. So when I'm switching the cameras, it's also talking to different products around. So it's more than just an RCP actually. So, but my point was really to show you what we can control on the cameras. So if I go to Paint 1, so I have a menu here called Paint 1. I have the gamma correction that I can play. I have the black gamma that I can also change. I can change my saturation. I can play with my details. I can turn them on and off. If I put too much details, then you can get some noise in the black shadows. So we have a denoise filter. So you can increase the detail, but also decreasing the noise, because they go together. So we have that filter. Then if I go to Paint 2, I get the normal matrix. So, you know, the red to green, the red to blue. So the normal matrices that usually the people in the field knows how it works. But it's really interesting when it comes to the multi-matrix. So maybe I can show you that. I don't want to make advertisement, but maybe I can show you that again with a can. How easy it is to change it. So
that's a suspicious red can. Could that be Coca-Cola by any chance?
I have no idea. I have no clue. I'm not paid by them, so I cannot name them. So So look how easy it is. So I will change the red, of course, as you certainly understood. So I can enable my gate effect again. So you see that I'm on the green because the green of the camera is on. I am on the vector 9. So let me come back to the number 1 or 2. Yeah, one is the red. So again, I can increase the saturation. I can increase the hue, and this is without. So you see off. This is without my changes, and this is with my changes. So you can see that the red is no more purple, or I mean pinkish, maybe a little bit.
Right.
So it's really.
But I guess the important thing is, because the way your camera is built, you can isolate a single vector without impeding any adjacent colors, any adjacent vectors.
Absolutely. So that's what we call secondary correction. So most of the color corrector are just playing on the primary corrections, which is just pure RGB correction. But
that's
when
very crude. That's very crude.
Yeah, that's really the difference that we have with the others. So
and you said it earlier. What's the maximum number of vectors you can control?
So usually, so the maximum we can do is 48. So it's really a lot, because then you have really a lot of a small nuance between the colors. But usually the people in the field, they like 12.
12 is good enough.
Yeah, I mean, we can do more. So if we have really picky engineers, we can really go with more vectors. But honestly, in the field, they are really satisfied with 12. So we can do more again, but 12 is really good enough.
Okay.
We have the knee function like on a Sony camera, for instance. That's also unique. Nobody in the POV has that kind of features. And then we have the white clip also, so we can also play with those tools.
Now, what does the knee effect do again? I don't recall. Explain that to us.
That's a good question. So unfortunately, I cannot show you here because I don't have the setup, but I can explain it to you. So knee is really to change the gamma curve at some point. That's the knee point. Because if at some point you have really a big contrast with like a window, and I'm in Belgium, so it's already the night, so I cannot show the window because it's just black outside. But the idea is really just to decrease the highlights, for instance, so that you are not burned in the high frequencies. So it's really
the window, like a window would blow the image out, so you can tame that
exactly
effect.
Yeah.
Okay.
Yeah. That said, I mean, we have also some auto tracking white, auto white balance, and things like that. And we can also weight the picture, so saying that side of the picture is more important than the right side, so it will not be affected by big windows that would really make the compute of the camera in the wrong way. So we can also add some weight if we want. But usually, again, people are using knee because it's really powerful. So a camera. So I mean, I can just screw up my white balance. So let me put it like this: red and blue maximum. So it's really ugly. I have just an auto white balance. Would be better to have a white paper and do it with a white, but
yes.
But that's good enough for the demo, I guess. So it's interesting to show you that, because that means also that you can play with the white gains individually. So you can play with the white and the red gains. You can do the same with the black pedestal. So you have a full control on the black levels as well. We have the master black. So you see that my pictures is really becoming grayish, but I can, of course, decrease it. So really, it's full control, like a broadcast camera in those really small cameras. So we have also here some mode. So if you see that here, I will show you that later in the slides, but we have also lens motors. So if you want to motorize also the iris, to have a control on the iris, I will show you some pictures. But my point is that here, as you can see, I can really play between the shutter and the gain. And the first line would have been my iris control. So I could control the iris from it. Then I can play with the gain. and then the shutter. And I can make a combination of those three settings, again, like a broadcast camera. So it's really complete in terms of control. Totally. So we have a totally button, but again, it's for CyanView because you know that they have what they call a CI0, so this camera interface. They have totally on it information, so they can link my camera with the totally. I forgot to mention something important, Jim. Our control, the control of my camera is RS485 or possibly 422 on some cameras. I know that in US you like 422, more reliable, of course. Not all of my cameras do 422, but I mean, some of them, the Atom 1 and the 4K does it. So the one you see now is doing 422. It's serial communication. And serial communication is always, you know, complicated in the field because of the length of the cable, the distance. Then you can, of course, bring some fiber solution, and I know that you have nice options for that. But CyanView is IP. So that means that we simplify all the cabling because everything is, you see just an RG45 here. And then I go IP RG45 until my camera. And this small box, if you put some PoE power on the RG45, at the end of the day, you just need to bring an SDI and an RG45, and you power the camera, you control the camera, and you have the image back for to the mobile unit.
So you use the CyanView CIO or RIO to convert from serial to IP.
The CI0, there's a new Neo that they have also, and we use that. Exactly. Yeah.
Right. We have another webinar that goes into that in more depth.
Yeah, I will not. I mean, I'm showing CyanView, but the idea was more to show my cameras and what they can do in terms of control. So so again, really easy to switch from one camera to the others. I think it was important to show you what the camera can do. So so here I will show you the pictures, but I have also my pan tilt controllers that goes through the CyanView again. I mean, it's really convenient to have a tiny remote pan tilt head with a mini camera on it. I mean, you'll see it's really amazing. So so Jim, I think it was important to show the features and to show the multi-matrix, which really make a difference with the competitors, and that's where we have our value. It's really about picture quality and really video processing. We have really a huge value for that, which is what matters at the end in broadcast, of course.
Right. The cameras have to match, absolutely.
So when it comes to control, so of course I did a small speech about CyanView, but for some customers that would already own Sony RCPs, for instance, we have also a kind of mini converter that translates the 700 protocol from Sony to my serial protocol from Dreamship, and you have the feedback of the value. So might be interesting. Of course, then a lot of limitation. We don't support all the features because some are really dedicated to Sony, and the point-to-point connection in that case. So again, with CyanView, you can control like multiple cameras. And when it comes to mini cameras, Jim, that's the idea. Because of the price and the quality, the idea is to add multiple angles. So it's not just one camera in the field. So and then there's another RCP called Scaroy that is doing also some stuff. Yeah, that's the situation. Maybe some details about the camera, Jim. So I will not make a lecture of all my slides, of course, because I know that everybody is bored with long presentations. But I just want to highlight some of the big points.
Give us an overview.
Yeah, exactly. So I really want to show you and some highlights on the camera. So the Atom 1 Mini is among our really small cameras. I'm speaking millimeters. I'm sorry, Jim. So I try to translate it in inches, as you can see on my third line. I hope that I've translated that correctly, but then you have an idea of the dimension.
Yeah, it's so really a little over an inch, it looks like.
Exactly.
Inches.
Yeah, because an inch is 2.5 centimeters, and we are at 3 centimeters. So it's a little bit more than 1 inch. So imagine that on 1 inch by 1 inch by 1 inch, you have an SDI camera with SDI connectors and an FPGA inside, because the CCU actually is in the head of the camera. So in that small camera, we have everything processed inside the camera, which is also an important point, Jim. Because most of the time people are asking me, okay, how fast is your camera? What is the latency of the camera? Because I've, like, for instance, an application, it's a concert hall with, how do you say that in English? The main guy that is leading the orchestra.
The conductor.
The conductor, yeah, chef d'orchestre in French, so conductor. And sometimes there's so many people that they don't see the conductor all the time, and they need to have a local monitor to see exactly how he's handling the rhythm. And I can tell you, you cannot afford to get latency, because if you have some
they'll miss their cue.
Exactly, and then it's on the wrong moment. So we have almost no latency because, I mean, everything is processed in the FPGA that is really inside the camera. So it's really a question of 1 or 2 lines on 1080 lines of delay. So it's really nothing. I mean, it's really microseconds of delay. Let's say there's no delay. One of the applications of the camera is that application, because of the no latency issue that we have on the camera. So
well, I see here too at the bottom there, you have, this supports the multi-matrix. Now, a camera this small from another manufacturer, you'd have to have an external color corrector, right?
And I don't know many that are really having multi-matrix inside. So most of them are, I will not say names, but I mean, everybody knows the color corrector that you can find on the market, except one that I know. Most of them have no multi-matrix support. So and
RGB crude correction.
Exactly. So you have some gamma correction, you have the primary correction, so RGB, as you said, exactly. But when it comes really to the matrix, then you don't have that. And then that's also some cost, right? Because that's right. Also quite expensive. So you don't need that. That's really important. In that camera, because of the size, of course, we are using a small sensor, which is a rolling shutter. So I guess that you know the difference between rolling and global shutter. So rolling.
No, explain that. Explain that to us that are not familiar with that.
Yeah, I mean, it's quite easy. So the shutter, when you get a rolling shutter, so it reads line by line, and then a global shutter, it really reads at once the full sensor. So the difference is when you have a racing car, for instance, with a lot of bumps and rolling, and then you can really have some blobs on the pictures, and it's not totally smooth when it comes to rolling. And when you have a global, then it's really straightforward. It's not moving at all.
It's capturing the whole frame at a time instead of a line.
Exactly. Yeah.
Gotcha.
That said, we have a kind of fast rolling shutter, so we don't really have this rolling effect problem. My cameras are used at NASCAR, 24 hours of Le Mans. I will show you a video of Daytona 500 that was taking place like 2 or 3 weeks ago in US, and on a drone. It's a super cool application of the mini cameras, shaded live by Cyan View for Fox, and I will show you the video just later, and you will see no effect like that. So at the end of the day, I think that we have a very good rolling shutter, but global will be, of course, a step further, and we do have, of course, global shutter cameras. So I will come to that in the next one.
I should say, I'm not doing my job, Stefan. Couple of questions. Really? So one question, can the cameras also work with Rec 2020 color gamut? Do you understand that question?
Yeah, of course, a very important question. And yes, of course, because we are HDR, so we have the Rec 709 gamut, but we have also the 2020, of course. Very important question. And I was not doing my job properly as well, Jim. So It's one to one. That's perfect. But yes, of course.
Then another question: what video formats can we record to? I assume it's 1080p, 60. It's SDI, so any kind of an SDI recorder. It's uncompressed video.
It's uncompressed SDI, and we cover all the frame rates. So also including the cinema frame rate. So really going from 23.99 to 59.99. And all the intermediate frame rate from Europe, Asia, US. So yeah, we cover all of them. So all my cameras are 1080p HDR, but they can be interlaced. I mean, I can also output interlaced pictures, of course, 1080i 50, 59 from the same camera. I will show you the next one because it's interesting regarding the frame rate. I will explain you that just after. Okay, for the question at the moment.
Yeah. Keep going.
Okay. So for those mini cameras, they are so small that usually we are using M12 S-mount lenses, and we so usually those lenses are quite bad because that's really basic CCTV kind of lenses. But the one that we are providing, I mean, we did really extensive research on the market, and that one is really sharp. So again, as I was showing before, that's that lens that I'm using here. Trust me, the picture quality is really good and really sharp.
Yeah, the go-to meeting, the go-to webinar quality may not be good. I'm gonna make a blog post and have this video recording. I will also put some of the higher quality video links in the blog post. So if you want to, things might be a little, the frame rate might be a little low, the color might be a little off.
Because please believe me, it's really good here. So come in Belgium to see that. So M12, and we are also providing this really sharp and very nice picture quality lens, which is an 85 degrees, so it's really wide, almost 90 degrees wide, 3.4 millimeter. It's included in the price. So the price I'm saying is always including the lenses for the mini. When it comes to C-mount, which will be our next range that I will show just after, then you have the choice to buy the lens you want. So we are delivering a bare camera, and you put the C-mount you want. So so this M12 is 85. You can, of course, find other lenses on the market. So feel free to change the angle if you want. But that one is really good, and it's provided with the camera. So interesting. We have a microphone also on that mini camera. Of course, don't get me wrong, it's not a Sennheiser quality level camera, but microphone. But that's the kind of microphone we put on the mobile phone, and you know that mobile phone nowadays are really good audio quality as well. So it's really an SMD flat components. So you can really get some good ambient noises or the crowd in the stadium, or whatever.
Or it could be backup to your Sennheiser mic, and I
absolutely, yeah. I mean, my customers are using it, so it works. So it's embedded on the SDI, and it brings some sound, of course. So yeah, weight 45 grams, again speaking grams and kilos. So, but it's really light. That's my point. If that one is too big, we have a smaller one. So we have the Atom 1 Mini Air, which is 3 by 3 by 1.8 centimeters. So it's less than 1 inch. So that one is super small. That one is so small that you don't have SDI connectors on the camera. There's no place for it. So we have 2 breakout cable, which facilitate also installation if you want to get that really in some places. And you will see that in my application, the kind of places we can fill. So same sensor, same camera, same control. It's just that the size is a bit different. For the rest, it's exactly the same camera. Then we have the waterproof. So that's the one I was showing you here at the beginning. So a very small one. Again, the same camera, same PCB, same sensor. It's just that you have a waterproof housing around. it's really waterproof. So really, I can put it in the water for swimming pool application, or I mean, whatever thing. Of course, the idea is to put it outside, so it's weather resistant. But it's more than weather; it's waterproof. So so you can really put that into the water. Same lens, same everything. It's just so three cameras that are just a small difference because of the enclosure, because of the external housing. So, but same product at the end. So same picture quality. Then I come to my best camera. I like that one because it's really good. So that's my Atom one. So that's this small POV. So you see it's really in my hand. You have a global shutter. You have a 2/3 inch global shutter. So that's simply the smallest global shutter of the industry. You have nothing smaller than that camera with a global shutter. So picture quality sensitivity, because of the size of the sensor, is also really good, because the previous one was having a smaller sensor. So no miracle, of course, the sensitivity of the photosites with small photosites, I mean, it does the job, but of course, if you have a bigger sensor, always better. So,
Right.
So global shutter, you'll see on the picture, but also on the camera, that I have 2 SDI out and 1 sync. So I have a gen lock on that one. So that one can be gen lock, like black burst, 3 level, like a normal broadcast camera. And the size is still really small, as you can see. So 3 by 3 by 6, so 1 inch something by 1 inch something to 2.5 inch. So still really small. And that one, because 2 SDI output, you can have 2 independent SDI. So for whatever reason, you could have one in 1080p and one in 1080i at the same time.
Wow.
So you can make a production in interlaced and recording in progressive, or vice versa. So it's really up to you. We can ingest also on the other cameras, but especially for that one, lookup table. So we can add lookup table LUT 3D LUT on the Atom 1 Mini, but that one also. But then I can have an SDI with the normal SDI output uncompressed, and then the SDI2 with a look. So you can add a look on the SDI2. So very nice camera and really sensitive. Very interesting. Then, because UHD is coming, of course, we have 4K cameras. We have 3 models: the 4K Mini 7, 11, and 16. Those are the same size, so the same body. It's just that the 4K sensor, one is small, one is medium, and one is large. It's like at the McDonald's, you know. So you can get like different menus. So you can size it, so and you can upgrade it, I think. So so 4K Mini 7 is a small sensor, very good camera, affordable broadcast quality, 4K. So very interesting for the people that wants to step in the 4K world, because again, dream ship quality with S-mount lenses. So that's the same S-mount that we put on the Atom one. I mean, great camera, really, honestly, a very nice one. Then the Mini 11 is really interesting because it's a 2/3 inch camera. And because it's a 2/3 inch camera, you can add a B4 ENG lens adapter. So you can have like a nice ENG camera with a mini camera at the end, and you shoot 4K with a broadcast quality lens. So that's really impressive. So so that one is really good for that kind of specific application. That one, like the Atom one, is C-mount. So we are not into the S-mount anymore. And C-mount is really I mean, more and more like Kowa lenses. You get really nice lenses with very good picture quality for C-mount nowadays. Maybe let me just say something, Jim, because I have also always the question. We do POV, so point of view, wide angle. So you put that behind a basketboard on a gimbal to get the action. You need to be close to the action, so you need to see really wide. I've often the demand to get, okay, what about the zoom? When it comes to C-mount, the trade-off has been made in a way that C-mount, you don't really find good zoom lenses at this stage. Because again, we were more into the wide angle stuff. That said, Computar, which is also a very nice brand, is launching a zoom lens for 2/3 inch in C-mount. So zoom lenses is coming. We are testing them with the manufacturers, but that's coming. So that's why the Mini 11, so the previous one, is interesting, because if you really need a zoom, most of our customers, they own already ENG lenses. So they just take it off the shelf, they put it on the camera, they want to zoom, there's a solution. Because we are really in the wide angle area. But again, don't get me wrong, it's coming. So so the Mini 16, it's the last camera we have with fixed frame rate because of the slow motion just after. It's a 1-inch sensor, so it's a huge sensor, global shutter. So again, like the Atom one, that's the smallest global shutter 4K of the industry. There's nothing smaller than that. And again, just test it. It's amazing. So so very, very nice camera. So the C-mount lenses are not motorized. So we have developed a kind of motorization. So you can get lens motors that are fully controlled from the RCP for the iris and the focus, because as I've told you, that's fixed focal length. So you don't have the zoom, but then for the iris and the focus, you can control them remotely. And iris control is really also something really important. That's the micro pan tilt head that we have. So you remember my video here. So that's the video. So that's the control with the CyanView and the joystick. That's the micro pan tilt head. So you can, it's really smooth. You can really use presets position, recall them from the CyanView. You can also control it from the CyanView itself, because it's a touch panel. It's a touch screen. So you can play with your finger on the touch panel to move the pan tilt, simply like that. Or of course, having a joystick like I do is obviously better.
I've seen like the operators following like the hockey puck in hockey.
Exactly.
I don't know how they do it. They got the PTZ controller.
Yeah, but you need a very fast.
They can't blink. They don't blink. The operators don't blink.
Yeah, that's crazy. You don't see that. I mean, when I just attending that, I don't see oh, do you say the puck or?
Oh, the hockey puck. Yes, the puck.
Yeah,
yes.
the hockey puck. Okay, yeah. Right. So it's so fast. That's where you need slow motion.
Good segue.
Yeah, of course. Yeah, slow motion. So of course for the production, but also for the referees. Also important to see that the puck is inside or cross the line, or so it's also interesting for referee camera. I will come to the slow motion just after. So micro pan tilt, impressive micro pan tilt head. Look at the size of the XLR connector. So you see the size of it. It's really small. So don't forget that the camera that you see on the pictures is this one. So I mean, it's really small. It's weather resistant. So you can use it on the outside and combine with my waterproof camera. So you can put this pan tilt outside in the rain and it will work. So there's a famous boat race at the moment that is really famous with really high speed boats. I cannot name the race, but it's really famous. They are using those ones on the boats. So so it's really on the sea and it works really good. So so micro pan tilt head, so same gears with my lens motors and 4K, so it's supporting all my. So what you see here is really the camera. So this one, so this one is really my micro pan tilt with the Atom 1 Mini Air that you see here with the CyanView. So that's the CI0 below it with the tally on. And again, I have big fingers, but still it's really small. It's really incredibly small. And you have like a full 1080p HDR, remotely controlled, and really for not a lot of money, because the pan tilt is the same kind of pricing that the camera. So like for 2000 something, you have like a broadcast camera with a pan tilt head. So
as you
really
said there, the CyanView box, that's, what is that, a CIO? That's doing the serial to IP
absolutely
conversion.
So you see that on my left pictures. So I have this RG45 coming in the camera interface, and then they have two iROSI connectors, and one goes in the micro pan tilt head for the control of the pan tilt head, and the other output goes directly in my camera. So the CI0 can control two things at the same time. Can be two cameras, two different cameras, or a camera and an accessory like this pan tilt.
Right.
So
and you see how Stefan has it mounted. The Cyan View has a 1/4-20 mount on it, so you can put it between the mount or the tripod and the camera.
Everything together.
Kind of stack everything all up nicely together.
Yeah,
it's better than Velcroing or duct taping things together. It's a nice integration.
I mean, you can do that if you really love Velcro, but you have really an engineering. I mean, David is a clever guy, so so he did it really well. And the last one is just a normal joystick, just to show the size. So you see there's no Photoshop behind. It's really the pan tilt next to the joystick.
The joystick's bigger than the camera and the PC.
Yeah, this is really really crazy. We did some waterproof housing for the other cameras. So we have the small camera that I've shown, the Atom 1 Mini waterproof. For whatever reason, at the moment it works only with the 4K Mini 7, but we are working also on housing that will fit all the cameras to protect them. It looks big, but look again in my hands, it's really small. So it's really a small product. Slow motion. So let me take some time to explain you the slow motion, because it's a really cool system that is quite unique. Again, unique for two reasons. The first one is because of the price. It's really cheap. I'm always saying that I was fighting with my CEO because I thought it was too cheap. That, as we said, we are leaving money on the table. And my CEO said, no, we just want to enable all our customers to be able to reach that technology. So I think at the end of the day is right, because there's really nothing, Jim, on earth at that price with a broadcast quality camera. I mean, there are some competition. I know it really well because you know my past with iMovix and the slow motion. So I can tell you that the pricing is nothing to do. So let's say that we are around 10K US dollars for that camera. iMovix was like 200K. So it's really nothing to do. Don't get me wrong. Of course, I mean, if you go to a Sony slow motion, the 4800, for instance, I mean, that's, I don't know, 100K. Let's put a price. Of course, I'm not saying that we will replace them, but for the money and for the price difference, we are not 10 times less good. Right. It's really close.
Not every production has the rental or the purchase budget for 100K.
Exactly. Now they can have it, and I will compare it. Maybe it's maybe a very good comparison or not, I don't know, but with the Phantom camera, because we have the same kind of workflow than the Vision Research Phantom camera. I will explain you why. So the camera, I mean, again, trust me, it's smooth and it works really fine. So I'm just shooting a turntable here. I got this again, very easy. Oh, sorry, I need to change my angle because I want to show you this. So I got this jock shuttle to control. It's just a basic shuttle pro. So you see, it's really basic, costs really nothing. link to the CyanView, and CyanView make the bridge to the camera. So let me come back to the replay output. So really easy, or maybe I can do that so I can show both at the same time. So so you have the live and the replay that is always available. So that's two independent outputs. So live is strong. It's a strong output. So you have always the live that the director can just cut live. And then you have the replay, which is independent, and it's a different video processing. So you could have like different colors if you want. Nobody's doing that, don't get me wrong, but you could really have different colors if you want.
Right.
And it's easy. So so at the moment I am in what I call the trigger mode. So I'm triggering the memory. So I'm recording internally in the inside memory. I'm just triggering the memory, and then I have my slow motion 500 frames per second. Of course,
and the jerkiness we're seeing in these videos is due to the very low and jerky frame rate of GoTo.
Yeah, I'm sorry about that, but I can tell you in the nice video, I hope that you will be able to collect the video in a nice way, because it's really impressive.
We have some Vimeo recordings that I will put up on the blog post.
Yes, please, because it's really working fine. So I can tell you. So same video processing, FPGA. I mean, not same FPGA. It's a really big FPGA in that one, because you need to handle 500 frames per second. So as you can imagine, the amount of data is huge. But same video processing. That was my point. So same multi-matrix, same everything, like on all my cameras. So if I want to change now the so let me come back to this one. If I want to change the red, again, I can go to my paint, multi-matrix, enable the gate effect, and change the red of my car if I want. So really same video processing. So you can really paint it like a normal broadcast camera if you want. So so that's the first.
Yeah, back to painting control, right? With slow motion cameras, you need a lot more light, correct? So then the color balance could be off.
Jim, of course, because you are taking 500 frames per second, so the shutter is closing 500 times per second. So you take a tiny amount of light.
Right.
But we are using the latest generation of Sony high-speed sensor in that camera. Don't get me wrong, the Atom one is more sensitive, of course, but it's only 50 or 60 frames. That one is one of the best sensitive camera in slow motion that I've seen on the market. So it's really using the latest technology. So, I mean, in US, I don't see any problem, because most of your lighting and stadium are really well equipped.
Yes.
In Latin America, I mean, we sold 2 cameras in Argentina recently. They were used in Brazil, and that was working fine, actually, even with bad lighting, because, I mean, of course, the level of quality is different. I have some pictures. I will show that to you just after. It was working, but in America, in US, that will be perfect. So so really no issue here. But you are right, sensitivity is really important. So so I will not explain every detail. This workflow is interesting, because that's the 2 workflow we have. So the camera is a kind of 2 cameras, if you want. So we have the trigger mode and the SSM mode. So trigger mode, you record in the internal memory of the camera continuously. You have 60 seconds of recording, which is unique, Jim. There's nothing on earth that has that length. So just to give you an example, 60 seconds of recording means at 500 frames per second, almost 10 minutes of slow motion. So nobody in a broadcast production will use 10 minutes of slow motion live, because it's too long. I mean, everyone will just get out of the show.
The puck moving so slow.
You use that for the highlights, for a smile, right. For football player that is really happy, or it's really for this kind of emotion shots. It's just a few seconds. So really 60 seconds is really long, but we split the memory into banks. So we have different banks. And so you can record and trick the bank 1 while it's still recording on the bank 2. So you can play back your bank 1, for instance, and something happens because there's a fight, or I don't know, something, a nice flag, you know, flying on in the crowd when people will come back in the stadium. Then you can trick a second time while you are replaying the first bank. So now the second bank has something ready to show. No, I have 4 banks, so I'm also recording on the third bank. And so you have up to 4 banks. And really, honestly, that's more than enough. You don't need more than that. I don't see like 4 close action totally different that you should have. And then also the camera operator needs to have it in his sight. So
well, maybe Stefan, I think I understand the trigger, what it's used for, but maybe explain that. Like, so the goal is scored, the hockey puck is in the net. You wait till the action stops.
So it has been recorded because it's a loop recording in the memory, and then you have this. Let me switch to this one. So you have the slow motion remote. I'm just triggering the memory, and now I can replay the last live 15 seconds and go back in the past to see if what has been shot has been a goal or has been a fault or something like that. So so you can come back, and I can free the bank and come back to life. And I can do that 4 times. So I have 4 banks to do that. So one example would be a goal, a hockey puck that goes in the goal. So you trick to get the goal, and then you have the, I don't know, the trainer that is really mad from the other team, really having like bad reaction. You can also record it. Then there's a fight between the hockey players at the same time. Then you can do that, and then there's a beautiful lady, you know, waving the air in the crowd, and then, you know, doing some dance or whatever. And then you can also trick the memory and record that girl at the same time. So the idea is really to trigger mode, to push a button to stop the recording, so it's really frozen. The last 15
seconds. Save the recording.
Yeah, exactly. It's saved in the memory. If you would have a problem, I don't know, you restart the camera, that clip is saved, so it's really saved in the camera. It's not like RAM, it's really like SSD drive in it, so it's really recorded on the SSD drive. And then you output them on SDI live. So the workflow is that. So if I come back to this one, so the workflow is live. So you just replay back the live from the memory, and then the director can directly cut it on air because it's a live SDI. I mean, it's a replay SDI feed, so uncompressed SDI. So we don't really make like compressed clips, like, I don't know, Apple ProRes clips inside. It's really the live SDI that we have frozen. So
there's no compression. It's you're
no
playing
compression.
back the live recording. And the trigger, you trigger the event. You trigger at the end of the event you want to catch. So the goal just happened. I hit the trigger. Now I've captured the 15 seconds before the trigger. So I got the player coming to the goal. I got the puck being shot into the goal. So it's
inside. The action is done. I triggered.
Gotcha.
There are ways. I'm not sure that we have already implemented that, but there's also a pre-trigger time. So you can also trigger, and then it will just take the next 15 seconds. So there's 2 ways actually, but I'm not sure that we have
before or after the trigger. Both.
So at the moment it's before, but we could do after. It's just a question of programming the camera. I'm not sure it's already activated, but if somebody really needs that, like for horse racing, the finish line. So when the first horse is really coming next to the finish line, you trick, and then it will take the next 15 seconds. That would be the application, for instance. But usually the action is happening, you wait for the end of the action, and you trick, and you go back in the past. That's the usual workflow. Trigger mode. And then we have SSM mode. So you know that on the market, Jim, you have like SSM cameras, super slow motion camera. So you are pushing phases. So like 20 years ago, maybe, no, because time is flying. You had the first Sony 3 times, Grass Valley 3 times. So we do the same. So we have 2 phases, 3 phases, 4 phases out of the camera. So you can reach 240 frames per second with a continuous recording. So you push that in a EVS, you push that in a Dreamcatcher, whatever ROS server. So you push that in a broadcast server, and then it's recorded in the server, but continuously. So everything is slow motion in this case. That's a very interesting workflow also, because then you have everything in slow motion, and the operator is just using his server like usual. Of course, pro and cons, then you reach only 4 times 60 frames per second, so 240 max. So if you want to reach higher frame rate, you need to go in the trigger mode. But because it's the same camera, you could make the first half time in trigger mode and the second half time in SSM mode. You just restart the camera in the other mode, and it's ready. So you can also be a bit, creative around that. So I hope that we don't lose too many people at the moment. Because I mean, I'm getting to the end slowly. I would like really, after the slow motion, of course, speak a little bit about the Barracuda and show you the use case. 2 nice case study that we had recently. So let me maybe.
This is all good stuff, Stefan.
Okay, perfect.
We're learning a lot.
Excellent. So the SSM 500 has 2 models, 2 versions. One is C mount and one is B4 mount. That's 2 different models. So we cannot change the mount, unfortunately, because the demand was coming too late in our development from the market. So we have 2 different cameras. But I don't think it's a huge problem, because first of all, of the price of the camera, but also because it's 2 different applications. So C mount would be more like on a pole cam, or like on a crane, or like on a gimbal, so really close to the action, like a POV slow motion with a wide angle. So mount, and before would be more like a static camera with a camera operator with a big box lens, broadcast before lens in front of it. So again, I'm not saying I will replace all the existing slow motion, but I'm sure because of the budget, that will be super appealing for our customers, because it's really incredible when it comes to the price. So it's 2 different applications, I guess, for me. Controls, you've seen it. So this is a Shuttle Pro. We can be controlled by Cyan View. They have integrated the Shuttle Pro, but also the GL Cooper, that American brand. So it's also possible. That's the kind of application we have at the moment. So like on a pole cam. So the one on the left is from Torneos in Argentina. So they were using that on the football for Latin America. So a kind of super big final stuff. So those guys in Argentina are already using this camera in Latin America. So on the right, that's I think, I will be killed by the football fan in Europe. I don't recognize the stadium, but I think it should be Manchester United. But please don't kill me if it's not that. It's in UK, that's for sure. I think it's Emirates Manchester, but again, I'm not totally sure. But it's really famous.
You're in trouble now.
Yeah, I'm in big trouble. So, and one of the other applications that you see above is the Atom one on the kind of magic arm behind the goals with a wide angle from Kowa. So that's the kind of a soccer, because that's our football, of course. Another very interesting application is what we call the flying cam, the wire cam. So that's those cameras that are flying over, the stadiums. Then they can use my camera because it's light, small, and with slow motion. So so that one was used recently in Portugal. So in Porto, which is one of the big football soccer team in Portugal. That one I know because it's written on the stadium, so I can read it. But so that was a nice application. when I come to application, so maybe some example of what we are doing, Jim, and I have a nice video to share with you guys in a minute. So of course, because of POV, mini cameras, reality TV show, really important. So shows like Ninja Warrior, or you need really tiny cameras in tiny places. You cannot put the big broadcast camera, and then you are using my camera. Super Bowl, so that's what I was telling you. So we had that in the line to gain pylon cams for this Super Bowl. So I'm not really into the rules of American football, of course. So I've been told that line to gain is an important one because it's moving with the teams.
Right.
So it's flexible, so it's also wireless. So of course, super proud to have been on the Super Bowl. Daytona 500, so I have a very, very nice video. Let me show it to you. So sorry for the quality, but again, I can tell you it's fantastic. So they use that on drones. So Fox was really flying next to the racing cars. And again, I mean, I can share the video with you, Jim, because it's really nice. They were really closely to the action, fully shaded and painted by Cyan View. Use live, so because they were able to match the other cameras. So imagine the potential that you can get with drones on those applications. So that's really, really, really cool. So a very nice application that we had in US also recently. So it's car racing. You see ice hockey, athleticism, football, ski. I mean, yeah, anything you can imagine where you need onboard cameras. That's the famous circuit for NASCAR. So Fox is using the 4K Mini 16 for NASCAR applications. Oh, maybe let me come back 1 second to that one. They didn't get what you said, Jim, that the camera interface is clever, so that you have a screw, so they just put tape around. So so it's not the way it should be, as you know. So it should just
They
be.
should have used the quarter 20 mount, or maybe that tripod there didn't have a quarter 20 mount on
I
it.
don't know, but yeah, that was funny because that's not what it should be, right? So so another sport that I don't understand, it's cricket. It's the UK baseball. So also very interesting for slow motion because it's also a very fast sport. So that's a very good application. Or in the grass, because you want to really have shots. You see on the right, you have some cameras really in the ground. So that's also interesting. A sport that is becoming really popular in Europe is field hockey, because we have no ice in Europe, so we do that on in the field. So but it's really becoming really popular. Esports, huge market, of course.
Yeah, big market here in the US. Yeah.
Super important. News. So because of the combination of the camera are so small with a global shutter, with a Barracuda, you can easily make a fly kit and make something easy to transport and to make a quick, setup for whatever. I think on the left, that was the game Spelling Bees. I think that's the famous spelling bees that you are having in US when you need to spell the words, right? So so they were using that with the Atom one also. And then cinema, because of the quality of the camera. So we have been on a famous production from a famous director in US that make millions of entrants with some blue characters in 3D. So you certainly know the kind of film I'm speaking about.
Yes.
I mean, 3D is really interesting with our cameras because 3D is still popular in cinema or documentaries, because it's really difficult to put in place with the depth of field and it's really. But if you have really tiny cameras, then it's really helping, of course.
Yeah, you can get them close together to have the proper.
Exactly. So I mean, it's not just the application; it's because of the quality of the camera, but cinema is also an application. Concerts, of course, very important application, not just with the conductor that I was telling you, but having a small instrument on the and what is about house of worship, super important, and especially with the COVID time. So really to spread the voice of God to the homes, always interesting to have that kind of applications. So I mean, there's no limit into our application, but I think it was interesting to show a little bit the application we can get with our cameras. Let's speak about the Barracuda, Jim.
Sure. So one question.
Go ahead.
Daniel here's got some really great questions. So he's asking about has anyone used the cameras in a at home or a REMI production? We've used the Cyan View technology with some of our bonded cellular at home productions, but we just started working with Dream Chip, so we haven't really deployed many Dream Chip cameras yet through VidOvation.
It's really new, Jim. That's normal. So yeah, we do, of course, and it's one of the 2 case study I'm having just after. So I will show you that just after. But definitely yes, because again of the quality, the size of the camera. So it's easy to deploy by one guy because it's small. So you put the cameras, you put whatever streaming device. I would prefer Barracuda, of course, but you can use whatever you want.
Yeah,
you can
right.
We are SDI, so you use whatever system you want behind. So
whatever the workflow might be. And then also the Cyan View helps to do the at-home production because RS-232 or 422 doesn't relate directly to the internet, so we go IP for control. That's a very important piece.
Yeah, exactly. And with the Rio that they have, so it's really made to go over the public internet in between, even with LTE connections just for the control with a SIM card. So yeah, definitely we have the tools to make it like a remote production. That's sure. So Barracuda, let me come back. Sorry, switch again to this view. So that's the Barracuda. So you see again, it's a small box, not big, up to 5 SDI inputs on one box like that. 3 different outputs. So we have the LAN, of course. So you just stream over Wi-Fi or a local network or a public internet. You do whatever you want. We have antennas because we have an internal 4G modem, LTE modem. That's a Sierra modem, so that's the most used in the industry. We don't do bonding, so that's also one of the difference with the competition, which is also at a different price level. So I guess that my product is interesting again because of the price, but we have different features. And we have also ASI output, so we can also transmit DVB SDI if we want. So using that for, I don't know, satellite communication or any ASI wireless RF transmitter if you want. So so imagine like 4 or 5 cameras H.265 compressed with one ASI output over RF, then the decoder on the other side, and you have 5 cameras over a single RF channel. So can be also very, very interesting for this kind of application.
So you have 5 SDI inputs. So do you have 5 independent encoders in there?
Yes. And they are really independent. I will show you that just after. So when it comes to 5 inputs, because we have a bandwidth FPGA limitation, of course, when it comes to 5 cameras, that's 5 times 1080p 30. For 4 cameras, then it's 4 times 1080p 60.
Gotcha.
And 1 time 4K.
Or then one 4K is another option?
Yeah.
Oh, that's interesting. So yeah, so it's just a throughput limitation. If you want to do 5, it's 30 frames per second.
Otherwise, it's 4. Let's calculate on 4.
Okay.
You see that on the connectors, I have also the same iROSI connectors that I have on my camera. So that means that if you battery power this Barracuda, you can power my cameras, but also control them. So if you use the CyanView on the other side, then you can also over IP, we do a kind of a serial tunnel over IP. to also control remotely my camera. So so we can output RS-485 at 115,000 baud, so it's really quick, bi-directional.
So you don't necessarily need the Cyan View. You port the serial control.
I mean, the Cyan View for the RCP, for the shading, but I mean, that's an option. But when it comes to flexibility and control different units, because that's really limited to my camera. So if you have a pan tilt head, then it's better to have the Rio on the other side, because the RI0 from Cyan View, because then you can control also different units. But if you have like onboard camera, like 4 onboard camera or 5 1080p 30 camera, then you don't really need other accessories. So then you can put everything in the Barracuda and just stream them over. So interesting information too, Jim. Because we don't do bonding, but not just because of that. Imagine that you have a problem with your network, or even over the public internet for whatever reason. We have internal SSD drive in the unit, so everything can also be recorded on the SSD drives. So that means that when you retrieve the connection through FTP, you could download the files and you don't lose anything. That's the idea behind. And we have also, I don't know if you see it, but we have the second antenna. This is a prototype, so I have only one BNC, but there's a second one on the picture. That's a GPS. So we can also transmit the GPS position of the unit, and the application would be like you are following a marathon or a bicycle race, and you can transmit the position of the motorbike that is following the runners, and then the mobile unit can make graphics, you know, with a city map and putting the position of the runners or things like that. So we can give the GPS position, and we have a CAN bus interface as well. So we've also a very famous motorbike competition in the world. They put the Barracuda on the bikes, and we can also retrieve, you know, information like RPM, speed, and make graphics on the other side and transmit that on the IP socket on the other side. They retrieve the data and they can use them to do whatever they want. So I have some workflow, so I will not read my slides. This is what I have explained. So I have some workflows that we did recently. So because of COVID, we had in our office in Hamburg, so the other office than Hanover, we have a church next to it, and they wanted to just stream live a kind of organ church concert. So 1080p 25, that's Europe. External audio connector, so you can also make a good a microphone or whatever, and getting an audio signal that you put in the box that you embed over the SDI, and then you can retrieve it on the other side on the decoder over the SDI or on the audio out, and then you put that in your audio matrix, whatever.
So it will take embedded audio from the camera SDI inputs, but also you have analog audio inputs, exactly. line level analog audio coming in?
Exactly.
Okay.
That's exactly the case. And then on the other side, you just output it using vMix or whatever, and you can stream online. At the moment, we have no RTMP, or let me maybe show you the next slide, because it's explaining that. Oh no, that's vMix. But then in this case with vMix, you just need an encoder, because then you get the SRT stream in your computer and you don't need a decoder from us. So the Barracuda is an encoder and a decoder. It's the same product, Jim. So what does it mean? You can, your customer can make a job one day having a point-to-point connection, having 5 cameras in, 5 cameras out, and the next day they can just, by updating the firmware, they can turn the decoder into an encoder. And so they have 2 encoders, and they can have like 10 inputs in this case. So it's all flexible. There's no license, there's no nothing. It's really flexible. Same product for the encoders and the decoder.
Can you mix and match? Can I make like three encode, 2 decode in the same box? Or
that's the $1 million question that we have every time. Not at the moment.
Okay.
But that's definitely on the roadmap, because, and especially with remote production, that's important to get a video return feed to the place. So streaming the cameras, but getting the program back.
Well, the solution to that problem is buy more boxes, and they're not very expensive.
You're a good sales.
But it's either five.
Again, just compare the pricing. You know, competition. You know the competition. I mean, they are really good. Again, don't get me wrong, but we are really, really affordable for the features we have. So maybe it's a good calculation. But we have that on the roadmap. It just demands a full FPGA reprogramming from scratch, because we need to route the SDI differently. So it's really a big effort. And we have a very interesting roadmap. And so we have really some priorities. We will get there because it's really important, but not at the moment. So, but that's definitely on the roadmap, because that's important. It's really more than a nice to have. That's really important to have it. So this is what we have at the moment. So sorry, I see that you don't see all the, maybe if I do this, yeah, you see.
Yeah, that's better. It's cropping it a little bit.
Better. So that's what we have at the moment. So that's really a picture of the features we have. So 5 camera, 4 cameras, or 1 4K. We have 1 stereo channel per SDI that we can transport. The goal is to have 8 stereo channels per SDI. So we have the bandwidth to do that, but it's on the roadmap. So we have already, like, if you put 5 cameras, we have already 10 channels on the SDI. We have an external audio in and can go out on the other side. But actually, Jim, as I've told you, that's the same product. So actually, we could also have like a kind of in-out. So having intercom in between, having also communication back and forth over the audio. So having really like a local, a distance intercom if you want. So that's also possible.
So you do 422 and 420. You do 8 and 10 bits.
Yeah. So really important. So when it comes to my products, so we are 422 10 bits. So it's really high quality HDR. So we are also transporting HDR. But when it comes to compatibility with other SRT decoders or cloud, data centers, there's more and more production in the cloud. Most of them are supporting 420 8-bit only.
Gotcha.
So we do support that, but we really push our customers to use 422 10 bits if they use Dreamship products, of course. But we want to be compatible with the widest manufacturers in the industry. So that's why we support 420 8 bits. And 420 8 bits will be also important when we'll get RTMP stream to get to social medias. So we don't have it now. So at the moment we support H.265 because we believe that it's really the latest compression codec. We have H.264 also in the box, but not in the GUI. So it works already on the control line level if you want to have H.264. But if you go into a web interface, because everything is controlled, so maybe it's interesting that I switch now to this one. So I can just reach a web page and I have all my menus accessible for the transport. So I can define transport, which can be RTP, SRT, or ASI. I can make multiple streams in the same transport pipeline or making different pipeline which are independent. So check this, Jim. So for instance, I have 4 cameras. So that's the 4 cameras that you see, of course, live with the same PID number. I do that because I'm streaming 4 independent streams. So the PID numbers can be the same because it's all independent. So I like this way because they are all independent. The pro and cons, as usual. The downside is that you have more overheads because you have like multiple pipelines, so it makes a bigger bandwidth at the end. Not that big, but it's bigger than having only one pipeline with multiple streams in it. So it's a question, of what you have as a bandwidth, and that's it. So the way it works, Jim, so you need to define a transport. So the transport is really, okay, what pipeline am I using? Am I using an SRT stream, an RTP stream, or ASI stream? So you need to define it. So if I click on it, you see, for instance, my SRT1. I am, you know, SRT, of course, you have like caller, listener, and rendezvous mode. So you define that. You put the destination address. If you have a stream ID for SRT, you can put it there. If you want to encrypt the stream, you can encrypt it here. And then you have some statistics. So if I refresh my page, so you see my statistics moving, and you see exactly where we are. So so I have 10 megabits of bandwidth used, but I have 60 megabits. So the first line is what is available for me. So I could really increase my quality if I want, and so I'm defining the transport. So first thing is defining the pipeline. Then I go to the program, and program is really defining. So let me click, for instance, on SDI1 program. It's really defining, okay, let me show you that first. So you have always a contextual help when you are leaving the mouse on one of the indicators to see exactly what you can do or what you cannot do. And like for the presets, so we have different presets. We explain what kind of latency we can reach with those presets, what is the kind of quality we can reach. So you know that this magic triangle between latency, bandwidth, bitrate, and then you need, of course, to put this triangle. So we decided to make 4 presets that you decide. So when you go to 4 low latency presets, which is the quickest one, we have low latency, we have reduced latency, normal latency, and high quality. Of course, high quality is buffering more, but you get more quality. So it really depends of what you need to achieve.
What the application is, or the quality of the connection.
Exactly. And in transport, then you choose the transport that you have defined before. So that's where you make the link with the transport you have defined into the program. Once this step is done, then you can do it 4 times, like I do here for 1080p 50 streams. You can see what is the frame rate, and maybe you can see it here, or maybe I can show it on the SDI. So let me show you the other SDI menu. So if I click on SDI, I can see what is connected on my Barracuda. So at the moment, I have 2 1080i 50 camera and 2 1080p 50 camera. So I can play with different frame rate, different interlace of progressive. Just a quick remark, we have found that it's better to use progressive with this kind of H.265 compression because when you have interlaced, you are really encoding 2 half frame independently, and to get the same level of quality than progressive, you need to increase much the bit rate than progressive. So it's really better. It looks like it's bigger to transport, but it's not at the end. Really, progressive.
It's more efficient.
And it's much more efficient for the quality. So I really advise to go to progressive. That said, we do interlaced. We don't downscale in the units. So if you want to get I into P or P into I, you need to do it from the camera itself or after the recorder. So and you see also the audio that I have. I don't know if you will see that, but yeah, you can see it. If I click on SDI, I can select also, that's where I select between 422, 10 bits, 420, 8 bits, and the different intermediates that I can play with. So because I was defining 4 independent streams, then I do really 4 independent streams. So that means they can be different with different formats, with different YUV compressions. It's totally independent. If I click on network, that's where I just, easily define my IP address. So using a static IP address or a DHCP address. And that's also where I can define my SIM card with my APN connection, PIN code if necessary. So the way it works, if I put a SIM card, it will always take in priority the LTE modem. and then it will falls back to the Ethernet if I have no communication. So if you want to use LTE, you just put a SIM card, define the pin, and it's gone. It's really easy to do.
Is there, how do you put the SIM in? Is there a slot externally to put the SIM in the unit?
Absolutely. So when I come here, let me show you that. On the back of the unit, let me maybe show you that here. I have two slots here.
Yes.
One is for a SIM card, and the other one is for a SD card. So I can record SSD drive or or SD card or USB. I can also put some drives on the USB. We are supporting the Linux inside. It's a Linux based, of course. So you could also put a Wi-Fi dongle if you want directly over there. So,
okay.
So network update, of course, is to update the unit and system. It's just to define the camera control. So that's why you do this kind of tunnel in between. That will be super practical when we get the VPN. So VPN is not implemented yet in the Barracuda, but having like the same network that you define under a VPN that you can define, then that will also simplify a lot of features on the Barracuda itself. So
very cool.
And of course, exactly the same. So if I switch to my decoder, same story. You define transport. So now I'm listening. Remember, Jim, I was calling on the other side.
Correct.
Here I'm listening to the port that I was mentioning on the other side. And then I define, okay, in the program, what is my transport I'm using, what video port out I'm using, what do I do with the audio? Am I using the SDI embedded, or am I using the analog input, output? What is my preset? So again, basic GUI, but at the end you do everything. So I like it because it's finally super practical and really easy to use. So
simple to use. Yeah, that's important.
I think so. So come back to the presentation. So I'm really coming to the end. I will show you the business case, the use case just after. So RCP control, I've explained that to you. ASI, so having like a wireless transmitter, RF transmitter in between, can be also one option. And then the case studies. So we come to the nice part.
So ASI, now the five HEVC streams are wrapped in a single ASI wrapper.
Exactly.
Correct?
Yeah.
Okay. And then that goes over the radio, and then you take that wrapper apart and give back the streams as SDI.
So that's why it's a super cool application, because you can have like multiple SDI over one RF signal. That's exactly that.
Very good. Very good.
Two case studies, one with Amazon Prime. It's about rugby. So that's maybe not something popular in US, but the point is not to speak about sports, but the application of the cameras. So I will explain you that, but let's start maybe with the remote production. So actually we were filming in the stadium Wimbledon in UK. One guy with Barracudas just putting mini cameras. They were just ingested in the Barracuda, and then streamed over. So that was in UK, and then that was streamed to Sweden, where there was a guy home that was racking the camera and making the production over a kind of cloud. So everything was so no decoder in that workflow, just the encoder streaming SRT to a data center. And then the guy was having the full control of video, layout, titles, graphics, and was making a production that was just put online on some social media. So very easy, simple, because of the size of the camera. It was mix of 4K and HD production, and I mean really easy, combining our cameras and Barracuda. So a really cool application, because that, I mean, this COVID is of course a big issue, but it has also much accelerated the transition to remote production and to lower the cost and to put less people in the field and decreasing the travel cost. And so let's take the good side of what happened. So it was just an accelerator for that. So, and I believe again that we are with Dreamship in that route. So
Right. Well, I think we're all evaluating how we work, how we live with this new normal. So we're here to help facilitate what the new normal is going to look like, right?
yeah, so we'll see. It's just really long here because in Belgium we have really those strict lockdown. So I'm just seeing my computer and my bed like for a year. My last travel was US. It was in a year ago exactly. So really I miss to see my customers, to visit you, Jim, and
Yeah.
to visit some customers. So remote production is one thing, but also taking back our freedom and visiting the people is really missing me so much. So
Yeah.
the second workflow that I wanted to speak with you, Jim, because it's really great. I really like it personally. So you recognize a football, a rugby stadium, it can be a football or whatever. It's
Right.
more close to football than our soccer, of course. So the idea here was to make, so on the poles of the goal, you see these two white boxes. So inside the boxes, they placed 8 Atom 1 mini waterproof with 2 Barracudas. Every waterproof camera was used with a pan tilt head and going over Wi-Fi. So compressed with my H.265 encoders, going over a kind of Wi-Fi mesh network in between, then a fiber solution to the mobile unit, and everything fully controlled from the CyanView. And what we got with this kind of pictures is only feasible with mini cameras, because you cannot put a big camera and you can follow the action with the pan tilt, and you are really in the heart of what's happening. So it's fantastic. That's definitely pictures that you cannot get with a normal camera. And again, green correction, multi-matrix, you have everything here. So it's really the combination of cameras, streaming, pan tilt, control. I think we have everything here. So
Right.
that was really cool. So that one was a super I mean project, and also because it was for Amazon Prime in Europe, so it's of course a big name, and everybody was just happy with it. So it was really working great, and you see it's really, I mean, again, you don't have the quality of the pictures, but believe me,
it's stuttering a little bit, but that's the go-to webinar doing that.
It's really good. So again, a mix of everything, and being really close to the action, waterproof, and pan tilt, which is weather resistant. So UK is really known for the rain, so there's no problem for, it's not California. That's my point.
Well, we'll get a year's worth of rain in 1 hour. So when it does rain here, it's pretty
that's
bad.
crazy. Yeah, just flooded, right? So it's it's too much water at once. So I don't know what is the best option at the end. So yeah, so that was my really last slide. I will maybe just show you then for the social medias, and I mean, I know that Jim, you will of course give the information to your customers, but we have a Vimeo page where very interesting, really honestly, because it's really technical. It's really how you connect a CyanView RCP, how you connect my lens motors. We made some lens comparison for the quality, with the name of the lenses for the different cameras, the slow motion. David made also some webinars with us for CyanView, including EVS, how it's connected to the EVS. There's really a lot of videos that are really interesting. So yeah, Vimeo is more popular than YouTube in
Yeah,
Europe.
yeah.
We use Vimeo, but you can reach that. And then
Yeah,
we have the
I like what I plan to do is if you go a great place to go on the VidOvation website. Go to VidOvation.com and then go to resources and then webinars. You can sign up for upcoming webinars, but I put all the recordings of all the webinars there, so there'll be a
excellent.
recording.
Yeah.
And then with Stefan's permission, I'll
Yeah,
embed
sure.
some of these Vimeo videos in there. I'll make a resource page for everything we talked about today.
Exactly. Oh, let me use the opportunity here, Jim, because we discussed that before. For the customers or the viewers at the moment, don't go on the dreamship.de website, because that's the company website, and we did a dedicated page for the broadcast product, which is what you see here on my left, www.atom-1.de. So go there, because you have also the latest information. You can also, I didn't mention that, but we have also a kind of open source spirit at Dreamship. So every protocol, every pinouts, every technical information is available on GitLab. So GitLab is really, you know, the kind of engineering, software engineering, open source. We are really into that spirit. So if you Google GitLab Dreamship, you'll get to our Atom page, and you'll get all the information. If you want to integrate our cameras, if you want to use our protocols, if you want to make a special cable, everything is there. So we are
spell that. What is it? GitLab? How do you spell that, Stefan?
So GitLab, it's GITLAB. So like GitHub, but that's the other GitHub. That's GitLab Dreamship. So
okay. Well, I'll put that in the blog post. I'll get all that information, all the links, all the Vimeo, all the videos that you couldn't see very well today that were choppy.
I'm really sorry about that.
And
because
you
it's
can reach
so
out
beautiful
to
pictures.
I know our counterparts in Europe don't sleep, so they are available to us. VidOvation would be your front line of support and pricing here in the U.S., and then we will bring in Stefan and his team as needed. It's nice to hear that you're open. You have an open source mentality. Also, I heard a lot of things about you're adaptable to the customer's workflow. Every customer's workflow is different. You know, even with the triggering of the instant replay cameras, that we can adapt to your workflow. And I'm sure that you see these names here look very familiar to all of us. So they're not new to the U.S. market, but we're hoping to broaden the use of Dreamchip
and to grow it
and Atmos in the U.S. with the help of VidOvation.
Yeah.
So
that would be fantastic, Jim.
Thank you so much, Stefan. Thank you, everyone, for staying tuned. Give us about a week. We'll put all the information up online in a week. If you do have questions right now, reach out to sales@vidovation.com or call 949-777-5435. Thank you so much, Stefan. Have a great day.
It's a pleasure.
Thank you, my friend.
Thank you, Jim.
Bye-bye. Thank you, everybody. Stay safe.
You too. Bye-bye.